In this video, we'll discuss the halogenation of an alkane. Let's first take a look at how the electrons in this propane molecule are shared. The carbon and hydrogen atoms essentially share the electrons evenly. And of course, the carbon atoms are going to share their electrons evenly. So what does this mean if a reactive species comes along and tries to react with propane? In the case of a nucleophile, it finds no positive region on the molecule to interact with, and an electrophile is going to find no negative region on the molecule to interact with. So these alkanes are unaffected by the presence, but why? In the case of propane, all the electrons are shared evenly, and all the bonds happen to be single bonds, so there are no locations on the molecule that have any significant charge. The combustion of an alkane is a chemical reaction that we are all familiar with. In the case of a molecule like methane, it will react with two molecules of oxygen. All the bonds will break between the original molecules, and new bonds are going to form. In this case, we will form two molecules of water and one molecule of carbon dioxide. The other chemical reaction that alkanes are capable of undergoing is significantly more radical. Halogenation is a reaction involving halogens, of course, and though the examples you are seeing involve alkanes, we will see this with alkenes and alkynes in the future. When alkanes are involved, the halogen, fluorine, chlorine, bromine, or iodine, is substituted for one of the hydrogens on the alkane. The products are known as alkyl halides. The mechanism introduced in this video does not apply to fluorine or iodine, so only chlorine or bromine participate in this type of reaction. For this example, we will observe the mechanism for the bromination of ethane, but keep in mind chlorination is pretty much the same. The reaction requires a kickstart, which it will get from heat or light. The heat or light does not actually affect the ethane molecule, but instead the bromine. But what exactly happens to the bromine? Overall, the monobromination of ethane involves three distinct steps: initiation, propagation, and termination. During the initiation step, the bromine molecule is exposed to heat or light. The heat or light breaks the bond holding the molecule together. This produces two individual bromine atoms, each with an unpaired electron. These species are called radicals and are incredibly reactive because those electrons are looking to pair up. With bromine radicals present, the reaction continues with the propagation steps. If the bromine radical encounters an ethane molecule, a reaction will take place in which the bromine radical abstracts or removes a hydrogen from the ethane. As the process leaves an unpaired electron on the remnants of the ethane molecule, a new radical has formed. This ethyl radical is just as reactive as the bromine one, so it will also seek a partner for its unpaired electron. Should it encounter an intact bromine molecule, it will abstract one of the bromines. This forms the haloalkane called ethyl bromide. So because this process ends with a new bromine radical, it can start all over again, or in other words, it propagates. But during the course of the reaction, the two radicals formed can react with anything. If two radicals react together, their numbers decrease, leaving fewer radicals to continue propagation. The number of radicals will continue to decline until the reaction has effectively ended or terminated. During termination steps, bromine radicals can react together, forming bromine molecules. The ethyl radicals can react together, forming a larger alkane molecule, in this case it's butane, or they can react together and form a halogenated product that we saw earlier, ethyl bromide, which also goes by the name bromoethane. This process is also known as radical substitution, because at least when the halogenated alkane is formed, a hydrogen has been swapped for the halide. In summary, the mechanism is initiated with the formation of bromine radicals after heat or light breaks the bond of the bromine molecule. During propagation, one of those bromine radicals will react with the ethane, creating an ethyl radical, which reacts further so that a new bromine radical is eventually produced. Finally, during termination, the bromine and ethyl radicals will react either with themselves or together, ultimately bringing the process to an end. Thank you very much for watching. If you enjoyed this video, please like and subscribe as I have more in development. For my first ever video, I would also like to offer a special thank you to Grant Sanderson of 3 Blue 1 Brown, whose wonderful animations inspired me to try the same for chemistry. Additionally, I would also like to thank Matt Parker of Stand Up Maths, who always encourages his viewers to give it a go. And while this video does not have any maths or squares, I'm sure numbers will show up at some point, and I highly recommend both of their channels. Please feel free to get in touch with me via email, social media, or if you would like, make a request in the comments.